Welcome, everyone, and thank you for joining the second virtual DOE Office of Indian Energy Program Review. Next slide, please. And for those of you I haven't met, my name is Lizana Pierce. By way of introduction, I've been in the energy development space for about 25 plus years. Yes, I'm dating myself, I'm sure, but I have had the pleasure and the privilege of working with Native American tribes and Alaska Native villages and tribal entities for over the last 20 years. I'm a mechanical engineer by degree and am the deployment supervisor for DOE's Office of Indian Energy. And in that position, I execute the deployment program, which consists of financial assistance through competitive grants, technical assistance provided at no charge to tribes and tribal entities, and education and outreach. Additionally, I manage the national funding opportunity announcements and have acted as the project officer for many grants and agreements over the years. I also assist with outreach through our website, email newsletters, and oversee the support from our laboratory and TA providers. And with that, can you go to the next slide, Katie, please? Before we jump into the project presentations, I just wanted to go over a few event details. Today's webinar is being recorded and will be made available on DOE's Office of Indian Energy website in a couple of weeks. Copies of the presentation slides will also be posted on our website shortly. Everyone who's registered will receive a post-event email with the links to the page where those slides and recordings will be located. Because we are recording this webinar, all phones have been muted. We are taking written questions, and we will answer those at the end of the final presentation for this session. And you can submit questions at any time by clicking on the question button located in the webinar control box on your screen and typing in your questions. For presenters, please ensure that you're muted when you're not presenting. And because we are sort of on a tight timeline and we want to make sure that everybody has the opportunity to speak, please try to keep your presentation to the 20 minutes. Okay, so next slide, please. So this has become a requirement of the grant agreements. It's really to provide sort of the annual project progress updates as well. And when we have the opportunities to meet in person, it's a wonderful opportunity to meet face to face and network. We do invite all of those interested in Indian country to attend if they're interested in sharing the successes of these wonderful projects, provide an opportunity for information transfer, and hopefully learn from the lessons others have learned from. Okay, next slide, please. So this session, we're going to hear, it's sort of the Alaska session, if you will. First, we'll hear from Carl Hill, and he'll give us an overview of the Igiugig Village Microgrid project that involves using the river tides to generate energy. We also have David Mezhier, who will represent Hughes Village Council and their sustainable solar energy project. And we have Sonny Adams and Brian Hirsch, who will give us an overview of the NANA Community Solar Energy Development in the Northwest Arctic project. And lastly, we have Forrest Button from the Alaska Village Electric Cooperative, and he will give us an update on Stebbins and St. Michael's wind energy construction project. And with that, if you could bring up Carl's slides, Katie, and I will hand it off to Carl. It's all yours. Whenever you're ready.
Right. Good afternoon, I guess. Thank you. I'm Carl Hill. I'm the Vice President of the Igiugig Village Council and have been involved in our Hydrokinetic project for its duration, basically. Our project has gone through a couple of different phases. I'm going to present on the project as a whole. Let me see, I'm trying to collapse all of these windows over here. Okay, so our project is resilient and autonomous microgrid powered by marine renewable energy. And the cover slide here is RivGen 2.1, which is currently deployed in the river. And we can go ahead and go to the next slide. And we can go to the next slide as well, please. So Igiugig is located in southwest Alaska at the outlet of Iliamna Lake. You can see in the slide on the left the large lake that empties into the Igiugig River, where Igiugig is right at the headwaters there. You can see in the right slide, and you can also see the location of the RivGen deployment. That's where studies have concluded we had the best potential for hydrokinetic energy. Igiugig is kind of isolated from, or is very isolated from other communities. We have no road system connecting us to other communities. The only way into the village is by boat in the summer and by airplane in the winter. The large lake is also used as a highway in the winter, so you can get to Igiugig from other villages by snowmobile or ATV. Next slide, please. The project objectives to acquire and install smart microgrid electronics and energy storage to provide autonomous operation of the microgrid to power all village of Igiugig homes and facilities for sustainable energy supply and resilient operation. In part of the project objective that we try to keep in mind as well is trying to lower our energy costs. Our energy costs are very high. We are isolated from other communities. Our fuel is all flown in 3,400 gallon loads, and that's all of our heating fuel, all the fuel for generators, and any gasoline or avgas. Our power plant has 3 diesel generators. Each of them is 65 kW, and we use approximately 25,000 gallons of diesel per year. Next slide, please. So Igiugig Village Council is the governing entity of the village. We provide all of the services for the community, and we follow our people and values as far as trying to be good stewards to our environment. We have a large sockeye salmon population that navigates the river in front of us and provides much of our protein for the year. So it's on us to make sure that we're responsible with energy development in our area, and we do have a lot on our plate, kind of running the whole village. But one of our largest costs is electric utilities, and we are self-governed. We're a federally recognized tribe, so it's a big responsibility. Next slide, please. So this is kind of a timeline of how quickly things have happened around here. The Yupik people, predominantly Yupik in this area, arrived or started living here in the Igiugig area about 9,000 or 10,000 years ago. We had a commercial fishing economy that blossomed in the late 1800s. And then in the early 1900s to mid 1900s, the Land Claim Settlement Act, also known as ANCSA, occurred, where some of the land was transferred back to tribes. In '71, with the occurrence of the Alaska pipeline, we started growing more and more dependent on diesel, and that actually, it happened before the '70s, but we've become very, very dependent on diesel, and are realizing that we have to find some other ways to have energy independence. Like I said, we fly in our fuel, so we're very dependent on the fuel arriving in planes, and our fuel prices continue to go up, as does our government and electric subsidies, and people are out migrating, trying to find ways to diversify our energy sources. Next slide, please. So in this photo on the upper right is it's kind of an ironic photo. We have the RivGen system on the beach being assembled and ready to be launched as a fuel plane flies in with 3,400 gallons of diesel for our power plant. I think I'm probably going kind of slow here, so I'll try to speed up. But you can see on the left-hand side our total annual cost to operate Igiugig Electric Company in 2018. Since then, fuel prices have gone up a fair amount, and so it's actually costing us more than that now. But our electricity is 91 cents a kilowatt right now, and with PCE, we're down to about 62 per kilowatt hour, which is still very expensive. Next slide, please. So phase one of Adriatic Hydrokinetic project. In this photo, you can see the turbine generator unit being assembled with the rest of the base unit. Phase one was funded by DOE Water Power Technology Office, and Igiugig Village Council selected ORPC for the patented marine renewable energy technology that they have proven and are proving in tidal and river environments. Next slide, please. The technology selection, our basis for it was in an isolated village like Igiugig, you need to have as simple of a design as possible with as low of maintenance as possible. So we had looked at 6 different devices or 6 different technologies and chose the ORPC one because it met our need of attainable operations, and with local involvement, we're able to do a lot of the maintenance and O&M stuff on the RivGen ourselves without having to bring in specialists from the outside. Reduces operating costs. It gives us long-term viability with having our local folks be able to operate and maintain the device. Next slide, please. So in the left, you can see our assembly area, which is also our barge offloading area, right at the beginning of the Igiugig River and Lake Iliamna. You'll also see our modular barge with a 32-foot fishing boat that pushes it. And this is what we use to launch the device down at the project site, which is shown in the upper part of that. The photo on the right is from a drone, and you can see how clear the water is in the Igiugig River. And the drone has become one of our tools for maintenance. This is the longest operating river hydrokinetic project in the Americas at this point. Next slide, please. So phase one highlights we are very proud to be the first tribal entity to hold a FERC hydrokinetic pilot license. We've gone through a couple of seasons of out-migrating smolt and in-migrating adult sockeye salmon with no observed injuries or mortalities, which is very important to us. The device has survived 2 frazzle ice events. We have built up enough ice to bring the device to the surface. It did warm up and shed the ice and drop back down and start operating again. And we also went through a pretty severe spring ice breakup, and everything seemed to work out with a few glitches here and there, but everything continued to operate. Next slide, please. So phase 2 of the Igiugig Hydrokinetic project. We can go to the next slide. The phase 2 project funding was from the Department of Indian Energy, or Department of Energy, Indian Energy Office. This photo shows RivGen 2.1 in the background, or 2.0 in the background, and the new RivGen 2.1 in the foreground. The first RivGen, the 2.0, has been sent out for some repairs, and we had a lot of lessons learned on that device that we incorporated into this second RivGen device, and hope that it provides more reliability and durability. There's been a lot learned on both of these projects, and our project partners on this we still are working with ORPC, and then Schneider Electric is helping us with another portion of the project. Next slide, please. So the intent of this project is to have a microgrid that delivers baseload renewable energy from free-flowing rivers and tides. The ORPC RivGen and the battery energy storage system will be integrated with a smart microgrid controller, as well as with the diesel generators as backup. The overall intent is to have our battery energy storage system provide power to the village when there are enough renewables to allow that to happen. If something goes wrong, the diesel generators are the backup to charge the energy storage system, the battery energy storage system, so that the village can still operate. We did make sure that as part of the microgrid design, we're able to integrate wind power and solar power as well in the future when those opportunities arrive and when we've had time to develop those. Next slide, please. So I can give you a brief overview of the work we've completed to date and some of the lessons learned. Next slide, please. The work completed to date, during phase one, we installed, including the cabling to the shore station, the mooring device, and interconnection to Igiugig Electric Corporation grid. So that was the first project. As part of our second phase, we intend to get both RivGens in the river in tandem at the same time, and they ought to provide enough power to power the village for most of the year. Next slide, please. So this season, we were able to deploy the 2.1 and then install and commission our battery energy storage system. You can see a picture of the battery energy storage system here on the left in that Schneider enclosure, and then a transformer next to it that ties it into the grid. So we're still in the process of completing phase two. We don't have the microgrid controller installed yet, but we were able to charge the battery energy storage system and run the grid on that energy source by itself for about 10 minutes. So the whole village was running on batteries for about 10 minutes, which was really exciting for us. The storage system is rated for 253 kilowatt hours and has a 125 kilowatt inverter. Next slide, please. So as I said earlier on this first bullet, we're still in phase two of the project, and there's many lessons to be learned, I'm sure. I did visit Cordova a couple of weeks ago and talked with them about their battery energy storage system and got a few pointers from them as we're going through commissioning of our project. Anything that we learned in phase one, we tried to apply to any of the work in phase two, specifically with the design of the RivGen hydrokinetic device. We definitely have learned to work around weather, and the seasonality can impact our project timelines. Prepare for ice and prepare for more. We never know what Mother Nature is going to throw at us. Some winters we don't have much of an ice problem, and others we do. We're currently at the start of a very cold winter for us here, so it will be another interesting one. But communication is definitely a key between all the entities in the project team. As you can imagine, there are a lot of people involved in this. And one of the things that we came up with was a responsibilities matrix to kind of make sure that we weren't overlapping in any areas, and to make sure that project tasks were defined. Even though we did that, we are running into some things that were kind of, not thought of, and as we go forward, we're learning more and more. But it's all based on communication. And there's always plans for interconnection that are supposed to go as planned every time, and rarely do. But yeah, I think with this new technology, everyone's going to run into that. The next slide, please. And that is my presentation. I'd be happy to answer any questions at the end. And thank you for this opportunity to present.
Thank you, Carl. I'm sure there will be questions. It's a unique application. So, okay. Well, with that, let's turn it over to David Messier, When his slides are up, David, you can start. Give us an overview of the Hughes Village Solar Project.
Sounds good. Thanks, Lizana. Oh,
great.
Hopefully everyone can hear me. Thanks, Lizana, and thanks, Carl, for that great presentation just now. So I'm going to talk a little bit about the Sustainable Energy for Hughes Village Council project that we've been working on with the community of Hughes for the last, I think it's about 4 years at this point. I remember when I started going to DOE back when they were in person, intertribal or energy conferences, and Fort Yukon was always showing up year after year, and I thought, man, I hope I never have a project that lasts that long, and here I am many years later. Next slide. So the project for Hughes, Alaska is we're putting in a fairly large solar PV array in a remote community. Hughes is about 210 air miles northwest of Fairbanks. They're a Kaikon Athabascan community, and previously, until we just finished up a bulk fuel project last year, they were a fly-in only community for fuel. So that means just about 100% of their diesel fuel used for power generation was flown in planes that were DC-4s and DC-6s last built in the 50s and 60s. Next slide, which is a fairly tenuous supply chain for something that is so necessary in today's society. So the community of Hughes is fairly small. It's about 90 folks. They're growing slowly. I think they might be up to 100 by now, as they've been building new houses in the community and taking on new projects and programs at the tribe and the city. And the community overall is kind of one of the, I know personally, one of my favorite communities. I work with 6% of the federally recognized tribes. So we've got 37 federally recognized tribes in the TCC region. My organization is a consortia, and so Hughes is one of our tribes. And one of the really unique things about it, for all the folks online who work with other tribes in Indian country, is that the leadership is very stable in the community, and I think that allows them to take on and accomplish a lot more. Next slide. So as an example of that, these are just a few of the projects that the community has been able to take on over the last few years. And you know, they make a list, they work towards the goals on the list, and then they complete their goals and move on to the next one. And it's really awesome to see. I can contrast that in my experience from some other tribes, which kind of sometimes bounce from one project or aspiration to another, dependent on tribal leadership. And the community of Hughes, the first chief there is a gentleman, Wilmer Beatus, who unfortunately wasn't able to be here today, but he's also the mayor, and it just provides a really awesome opportunity to work with a motivated group of leaders in the community and get things done. So here's a few other projects that they have been involved with at the tribe and the city, and the tribe and the city up here in Hughes work really well together, which is another reason for the location of the project in Hughes. Now, oftentimes people ask me, well, how do you figure out which community to work in, or what project is most appropriate? And in my opinion, from my years of working with tribes, it really comes down to the local leadership. And I just can't say enough positive things about the community of Hughes. Wilmer, First Chief Beatus, sends his regards. He is recovering from COVID-19 at the moment. I talked to him this morning, and he sounded pretty rough, even though he's just out in a snow machine, blazing a trail up to the cemetery to bury a community member who passed away a few weeks ago. He is able to get out of bed today, but did not have the best experience with COVID. Thankfully, him and most of the community are vaccinated, but it's just been ripping through Hughes the last month or so. Next slide. So there's folks on the phone from all over the United States, both areas of Alaska and then the lower 48, and I'm sure folks know where their electricity comes from. Many areas it is natural gas, some areas it's coal, some areas it's probably nuclear. In the community of Hughes, almost 100% of their electricity historically has come from this small 40 by 30 building, the local village powerhouse. And I have the good fortune of serving on my local electric utility, which is a cooperative here in Fairbanks. I serve on their board of directors, and we always joke that we're the most important business in town. And if you don't believe us, just wait till the power goes out, and then you'll see how many people get upset. And the same is most certainly true for the community of Hughes, a village of 90 to 100 people. When the power goes out, you lose so many critical aspects that modern everyday conveniences or life kind of affords you. You lose the power at the clinic, you lose the runway lights, you lose the ability to run your Toyo heater stoves, which keep you warm at 40 below. It is very hard to run a remote school. Communications go down because they're all via satellite right now. So this building in the community of Hughes is incredibly important, and nearly 100% of the electricity in the community comes from this small building for diesel generators, and they pay about 7 times roughly the national average for electricity because all of the fuel that powers their remote diesel generators is flown in. Next slide. So the challenge for the community of Hughes was, how do we get from a fairly tenuous fuel supply situation, which is all of our fuel, the source of our electricity being flown in on these airplanes that were last built in the 1950s and 1960s, long before I was born, and move to a different reality that allows the community to take more control over their energy future. And for the community of Hughes, it meant looking at solar. Next slide. So many folks have asked me over the years, well, wait a second, I thought Alaska didn't have much sun. Why are you crazy nut jobs looking at solar? And so we pull up this map and we say, well, there is not a lot of sun in the community of Hughes compared to the lower 48, the Denver area, for example, or the Phoenix area, or heck, even Montana. But if you compare the solar PV in Hughes and the interior of Alaska to, say, Germany, which I believe still has the most solar installed per capita, though I'm not sure that's true anymore, but it certainly used to be in the world, we actually have a pretty reasonable solar resource up in Hughes. And more importantly, when you're doing remote energy work in far-flung villages, the proximity to the source of your power is a really key factor in making a project pencil. And so unlike wind resources, which can be located many miles away from a community, solar resources are often the same in the community, right next to the local distribution system, as they are miles away from the community. And so we began looking at solar simply because the only other option, next slide, was really the way things had already been done, which the tribe and the community said, well, we don't really feel super comfortable being tied to that tenuous of a supply chain for all of our power needs. Next slide. So back in, I think it was probably 2015 or so, the Department of Energy, Office of Indian Energy, was kind enough to send some energy planners up to the community of Hughes, and they had a few-day energy planning session, and the tribe out of that came up with a renewable portfolio standard saying, hey, we want to reduce our reliance on imported diesel. And they came up with a renewable portfolio standard, which many states around the country have adopted. And it was kind of serving as a guiding principle for Hughes. They said, well, this is our goal. So if that's our goal, how do we achieve it? We looked at different technologies, renewable, or I should say some of the hydrokinetic technologies that Carl just talked about didn't quite seem ready for prime time. Wind was potentially a resource, but located at least 5 miles away, and there is a needed multi-year wind study to determine if that's a viable resource or not. We had actually put up anemometers and then had a forest fire go through, which melted our data collection device. The tower's still up there, and we're trying to actually need to pull a data card next time up there. But regardless, a 5-mile extension line at costs of up to $1 million a mile make moving too far outside of the community to get your renewable resource a little bit less attractive. So the community said, well, what's available if we want to achieve this renewable portfolio standard? And again, solar kind of floated to the top as an option. Next slide. So in any remote power situation, or in our remote power situation, you've got an independent utility. Forrest is going to talk a little bit later. He is part of AVEC, Alaska Village Electric Co-op. In some of our communities, they are not part of a larger electric cooperative, so that means the resources for the community are a little bit more limited. They've got to find within that group of about 100 people, a water plant operator, a city manager, a tribal administrator, builders for new construction, teachers, somebody to run the clinic, and you've got to find some folks that know how to run and operate remote diesel generators, which can be quite challenging. So the gentleman on the left is Sean Jackson, the younger guy, And the older fella is Gilbert, Sam, and they are the two power plant operators in Hughes. I should say Sean is still the power plant operator. Gil has left the position, which is another challenge with turnover in rural Alaska, but that's the inside of the village powerhouse. Again, probably the most important building in the community. Next slide. And so our project, these were some of the goals. We wanted to, most importantly, increase tribal energy security and resiliency, develop a replicable PV diesel hybrid system that could be deployed in other villages, because the goal for this project was to just lead the charge using federal dollars, not to be the last project, but to be one of the first projects. And finally, to implement a financial model that would allow for tribal ownership, because that's tribal energy security if it's owned by the tribe, and also not negatively impact the power cost equalization contribution to electric rates, which is a state subsidy that reduces the residential electric costs in rural Alaska. And our goal here with the project is not just to increase tribal energy security and resiliency, but it's also to decrease costs for the tribal members, because when you're paying 70 cents a kilowatt hour for your electricity, it is not a good thing if your prices go up. That's not going to win you any friends. So next slide. As we started our project looking at the large high penetration solar PV array, we initially thought that the fact that our community was single phase generation and distribution was not a big deal. We soon realized that all of the available larger solar PV inverters and battery systems really did need to be three-phase. So that was our first hurdle, and we ended up working with the city and putting in an application for an ICDBG grant to convert the community from single phase to three-phase. And we did that fairly quickly in the grand scheme of things. Ran a three-phase underground line from building 16 over to building 13. I remember going over to the Episcopal Diocese, because number 13 is the church, and getting an easement for that power line, because if we had gone north, we would have went right through DOT Northern Regions easement, and they wanted to charge a fairly expensive annual fee to allow us to bury a line on their property. So I've been involved in a lot of different facets of this project, even down to getting the easements for the three-phase upgrade. So this is high level Hughes. A lot of the new area of town, the subdivision down here on the bottom below building 14 is kind of cut out, but that's the main area of town that we converted from single phase to three-phase and had to upgrade their switch gear in the powerhouse and the main run of distribution that kind of goes along the airport, and we balance the load and separate into three-phase. Next slide. And we also went through, because we believe that the cheapest kilowatt hour is the one that you don't use, and we did a community-wide LED lighting upgrade with some funds that were identified, and reduce the overall load in the community in the winter. And the biggest complaint we have from that project is that some of the folks said they had to sweep their floors more because they could see more of the dust in their house when we put in LEDs. And that was a pretty awesome project. Went through each home in the community, took out fluorescent incandescent bulbs and replaced them with plug and play LED bulbs, and reduced the consumption in the community, the load in the community quite a bit by doing that. Next slide. So this was the site of the solar array in 2017. It is a site just to the southwest of the power plant. And next slide, we cleared that site in 2018, and then next slide, got the solar array up. It was the first year that barges had gone up that high on the Igiugig River. And as you'll see in a later slide, the transportation is a little bit challenging from Fairbanks over to Hughes. You need to go down the Yukon, the Tanana and Yukon rivers, about 400 miles, then roughly 400 miles up the Igiugig River to bring these panels into the community. But if you do that and take the barge, then you can get your freight moved from Nenana to Hughes for about 55 cents a pound, which is better than the $1 a pound that the airlines charge to bring freight in. Next slide. So summer 2019, we ended up wiring the PV panels. Actually, can you go back to the last slide? I apologize. Wanted to point out Edwin Byfelt. He has been our contractor on this job. Great guy, he's from the one village down the Igiugig River. And we're really proud of the fact that all of the folks that put this project together were local folks. This is not something we brought in contractors from out of town for. We hired Edwin Byfelt to lead the installation I had gone up there and kind of walked them through how the components went together, and we put a few holes in there in the ground, sunk some helical piles, and Edwin led the crew and put in 120 kW solar array. And funny thing, this was his first solar project, so I'd say he did a pretty darn good job. Next slide. The next year we went through and wired the project up. Because again, we had never done a high penetration solar array that was this large before, so we're kind of progressing through it fairly slowly to make sure that we, and trying to control costs, because that's another large variable, I would say, working in rural Alaska. You really have to find the right people that can handle the challenges of working off the road system. When you run out of parts, it's not a trip to the hardware store, it is a call to a flight company, and there's no cell phones in the community, so you have to either use a sat phone or go over and find a landline, order your parts, and hopefully they'll show up in the next day or two on a flight. And so we're really proud. We hit this back in 2018 or 2019 with the wiring for about $2.10 a watt. And in 2019, next slide, we were told that if we wait 1 year and we put off the battery installation about a year, we can get roughly double the amount of storage, because battery prices were changing quite a bit then, for like 10% more. So we made the decision, well, we're not going to rush too hard. We'll wait until 2020 and put in our battery system that year. And so we installed a 335 kilowatt hour ABB E-mesh unit inside a Quonset hut for some weatherization protection up there. Wired it in 2020. And I'm not sure if you guys remember 2020, but there was a little global health pandemic that came by and pushed our project commissioning date off by a little bit. Next slide. And finally, we ended up getting the project online in 2021. There were a number of challenges that we hit with the integration of the ABB unit. I'll talk a little bit about the lessons learned later on, but it was a little bit of a process this year to get the project turned on, everything from global health pandemic to long lead time on items. We had some issues in the powerhouse. The community had, during this process, bit the bullet, installed a new generator. Syncing became a big issue. Our contractor for that project ended up coming, he developed cancer and basically had to leave the project to go down for treatment. So getting all the generators to sync was a little bit of a challenge. This is, mind you, all happening roughly 200 plus air miles away in the middle of a global health pandemic. So it was a little bit challenging, let's say, but we are working through it. And just earlier, this was a week or two ago, we were able to run the community essentially diesels off for about 4 hours, which is, if you look on the right side of that graph with a bunch of gyrating lines, that's the yellow area. And the pink line going in a downward direction is the battery bank state of charge, and that's being slowly drained as the village is running on battery power. So the solar panels were commissioned. Those are up and running, although we're not getting a large amount of solar production this time of year. And the community is able to run on the battery system, which is, I would say, the most complicated part of the project. And after 4 or so years, I was pretty excited to get this message from our integrators that day. And we are very excited to be able to turn the community off, or the diesels off, for a larger period of time next spring and hopefully summer. Next slide. So as I said, logistics was a big challenge. I hear folks talk about challenging logistics in the lower 48 all the time, and I think we could take the cake for the most part. This just goes up to Nenana, but obviously after we got all of the parts and pieces to Nenana, we had to then bring them 800 miles up subarctic rivers, and that was fortunately something that we do somewhat regularly, so it wasn't a big deal. Next slide. But the costs do add up to move all the material, and shipping becomes a larger portion of your project cost than it would in other cases. So we ended up getting our racking from Ohio. It got trucked to Seattle, barged to Anchorage, trucked to Nenana, which is where our barge is located, or the barge company is located, and then went down the Tanana and Yukon rivers and 400 miles or so up the Igiugig River. It was a little bit funny when I was going down to take a look at the load that was destined for Hughes that had the battery building on it. And there is a mine about 200 miles, or it's about 100 miles shy of Hughes on the Igiugig River. And I noticed all of the insulation for our battery building was for some reason in a pile for the mine. and was able to pull that out and put it in the proper location. That was a little bit of a almost foobar from our shipping company, that they had realized that the receiver was ruby marine, and it automatically input the last shipment they had for that receiver, and almost sent all my insulation 100 miles short of our destination, which would have been a real bummer, because we wouldn't have had any way to get it up except for by John boat, which is not designed for transporting pallets of insulation. Next slide. So this is the microgrid control package. This is a high-level look at what is running in the powerhouse. The time I took this screenshot, they were running on diesel number 2. It had about 54 kW worth of load. This was just last week that I took the screenshot, so you can see there's not any contribution from the solar right now, and the batteries are, I want to say, about 43% state of charge. So we are really excited for this project to come online, I guess, more fully next year, and we'll be ready for the sunshine when it hits in March or so. Next slide. This was kind of one of the, I don't know, challenges. We're very excited about the product. It's a new product from ABB. I'm not sure how many of you guys pay attention to the markets or large companies merging, but this was one of the challenges during the course of the project. ABB, which is a long-term partner of our integrator, Intelligent Energy Systems, ABB was purchased by Hitachi, and the ABB group that works on the power store had some growing challenges, or just challenges in general. So some of their key folks left, and it became a little bit of a challenge. And then we didn't really realize it at the time, but we were kind of on the bleeding edge, I would say, of this technology. And it was one of their first units that had been shipped out. So as our integrator says, the marketers kind of got ahead of the actual technicians and engineers on the product rollout, but such is life. Next slide. This is the modeling that NREL was able to do for us a few years ago. The area in red, kind of at that 40, where you see where it says 40 on the side, that's roughly their base load in the community during an average day in June. The blue area is what we're hoping to get from solar, and then you can see the electricity in yellow, kind of gold color. That's what we're hoping to pull from the batteries. So on a typical day in June, we're hoping to shave off a decent amount of generation from the diesel generators and get that all from the batteries and PV. Next slide. So delays we had a number of challenges from the project. We really didn't know exactly what we were doing when we moved forward. We had these ideas and some proposals from potential partners, folks that will take your money and do work for you. And sometimes, if as Carl said before, many of us up here in Alaska are trying to break away from decades and years of running these villages solely on diesel power, electricity produced from diesel generators. So there are most certainly going to be growing pains, and figuring out what your budget is for a project that nobody's done before with as many variables as we have can be a little bit challenging. So we started off with a budget of about $750,000, ended up the total project is going to cost us in the range of $1.1 to $1.2 million, and we were able to take advantage of the reduction in cost share from DOE, which was hugely significant, and we appreciate DOE putting that out as an option last year due to COVID. Next slide. And funding for these projects is so important, because when you've got a small rural powerhouse, a small rural electric grid like the community of Hughes, there's not many ways you can skin this cat and do a renewable energy project without increasing rates for everybody. So this looks at what it would have been had the community taken out a loan. Spread across such a small customer base, any project becomes incredibly challenging. So just again, I can't thank the Department of Energy, and the community of Hughes can't thank the Department of Energy enough, the Office of Indian Energy, for their support of this project. But suffice to say, it becomes a little bit of a challenge to make these projects pencil without significant grant funding. Next slide. So we had many challenges along the project. One of them was a cost-effective design, for both the battery bank and the solar in kind of a very changing market. You guys, I'm sure, have all been aware of what's happening with the battery market the last 5 or so years. It is not quite what I would call stable. And we're just kind of working through that, trying to make the decisions that are in the best interest of the community, the best interest of the project, and get the community the most robust system for what we can afford in the budget. We figured out the single phase limitation, got the equipment up to Hughes, and had to elevate obviously the gear out of the floodplain. This spot photo is from '94, I believe, where there was a huge floods on the Igiugig River, and this is part of our project site, I think, is in that photo, but it's kind of below where it says Igiugig River, below the airport there. So we had to get the the battery unit, the battery building had to be located on a gravel pad, which was conveniently already there, and then we had to get our solar panels up, and the higher the better was kind of the rule that we were going off of. And then obviously the implementation of an effective microgrid control system, working with your integrator and not negatively impacting power cost equalization. Those were all big challenges. Next slide. And the best turned out to be, we were trying to learn from this so we can roll it out more effectively next time. And I talked to our integrator, Intelligent Energy Systems. I said, let's kind of line some of these things out. So just so we're aware of them. And one of the big challenges that we had, not to knock ABB too much, but the factory acceptance test documents were never identified, they were never found. So originally we were really trying to get this project out in 2020 because we wanted to turn it on in 2020, despite the global health pandemic. And there were some, I'm not sure if there were supply chain shortages or what have you, but there were some delays that we heard about third hand, I guess, kind of a game of telephone. ABB tells our integrator tells us. And we made some phone calls and started rattling our sabers and making some noise. And ABB said, okay, well, we can meet your deadline because we know you only have one barge of the year that goes up there, but we're going to have to ship you a unit that was destined for Puerto Rico, which, as you might imagine, has a very different climate than Alaska. So a variety of challenges with the product, and again, it was early in their production cycle, and we're keeping tabs on all of the lessons learned in this project and hoping to improve them for the next one. So I think we can end there, and the information I don't need to read from the slide, but thanks everyone for their time, and I appreciate Lizana and all the folks at the Office of Indian Energy who have helped the community of Hughes and me along the way. Thank you guys for your commitment and, most importantly, your patience as we work through this project. Thanks.
Great. Well, it's been a long time coming, but I'm doing the happy dance quietly. Okay. And you can thank Carl for giving up some of his time because you went really long. But next, I'm going to invite Sonny Adams and Brian Hirsch to give a presentation on NANA's solar project. Sonny and Brian, you can start whenever you're ready.
Thank you, Lizana. Thank you, Carl and Dave, for some great presentations. It was good to see your projects. My name is Sonny Adams. I'm the Director of Alternative Energy for NANA Regional Corporation. I've been working for NANA for about 14 years. Prior to that, I worked up at Red Dog as an operating engineer and an operator. I'd ask Dr. Brian Hirsch to introduce himself.
Good afternoon. This is Brian Hirsch. I run Deerstone Consulting. Have the honor and privilege of working with Sonny and NANA Regional Corporation, as well as all of the communities in the Northwest Arctic, as well as some of the other presenters on this webinar today. So it's been really nice to see these projects moving forward, and we all, I think, share the growing pains. So look forward to talking a little bit more about it. Thank you.
Thank you, Brian. Next slide, please. So this is our NANA region. We're up in the Northwest Arctic. The size of our region is about 38,000 square miles. We have 11 villages. It's a roadless system. You can only get around by air, boat, or snow machine. We have the third largest zinc producing mine in the world, called the Red Dog mine. It's about northeast of Kivalina there. Our cost of energy is very high. It's 61% more expensive to live in our region than it is to live in Anchorage, and part of that reason is we have to fly in fuel into some of our villages. For example, Noatak, 100% of the time in the upper Cobalt villages, about 50% of the time we have to fly in fuel. And the reason is that we're not seeing the snowfall that we used to. So our river levels are more shallow and the fuel barges can't make it up. So we have to fly in fuel. Next slide, please. So this is the NANA energy vision, and I wouldn't so call it just the NANA energy vision. I think this is a regional energy vision. We've been working very closely with the Northwest Arctic Borough, AVEC, Kotzebue Electric Association, our tribes, our cities, our Deerstone Consulting, all of our partners, DOE, USDA, all of our villages. So I think it's a common vision, and we're starting to see results, and we're going to talk more about it, but we are meeting these goals. Ingomar seems to think that we're way ahead of the plan, but I think we're doing a great job so far. Next slide, please. So I talked about our partnerships and what it is that we're trying to do for our region. There's a couple of things. We want to make the transition from the traditional power grid to the modern microgrid. And the community solar arrays play a huge part in that effort. And so because of these partnerships that I mentioned, we're making great progress in some of our villages. And the goal here is to get to low cost electricity to where at one point we can put heat pumps in the homes and use low cost electricity to heat the homes rather than expensive diesel fuel. So we partnered up to do these microgrids and come up with a heat pump calculator to see if it's feasible to put heat pumps in some of our homes. And Ingomar and the Northwest Arctic Borough has done that for Ambler as a pilot project. They put in 70 heat pumps and 2 pumps in each village. So that's our vision. Our goal is to lower our energy costs for our shareholders and residents. Next slide, please. So talking about the first project that we got, this is a picture of Buckland, and it was the start of our project. We received $1 million from Department of Energy to install community solar arrays in Deering, Buckland, and Kotzebue. And our job was to come up with a cost share. And so NANA contributed some monies to help out with Deering and Buckland. That was $200,000. And Kotzebue Electric Association, our other partner, got monies from the Northwest Arctic Borough. And a lot of this funding is passed down from the Red Dog mine. So KEA, Kotzebue Electric Association, like I said, came up with $610,000 for their cost share. And we formed a joint venture to share ownership of the equipment during the grant period. And that JV is currently signed. Deering and Buckland used their VEDC monies, their Village Economic Development Committee monies, for their cost share. And one thing that we really want to point out is how NANA plays a role helping our tribes. A lot of times there's so much turnover, and that our tribes doesn't have these types of resources to bring these types of projects forward. They would even have trouble doing the DOE grant application. So NANA plays a huge role in supporting our tribes for the region. Next slide, please. So continuing on to talk about Buckland. This was a really unique design that Dr. Hirsch and his friend had put together. They put containers together. One of them was buried, filled with rock. Then they used corner locks for the top container. Then they attached the racking onto these connexes. And it was a little tough going at first, but once they got the system foundation down and put together, Box Power came in and was able to set up the racking. And the neat thing about this project is throughout the project, they used local hire. And so if there's a problem with the system, they can go back and fix it themselves. It's fully operational. It's integrated with wind and batteries, and it's the first multi-renewable hybrid diesel off system in rural Alaska. It was completed in December 2019. As I said, it's the first Box Power installation. And the community training was huge, along with the in-kind contributions that Buckland had provided. They provided gravel and equipment. And It was really a team effort there. Next slide, please. So this was the second installation. It was another box power design. One constraint that we had is Deering does not like to dig in their village due to artifacts. So we couldn't really bury the connex this time. What they did is they put super sacks in the connexes and used that as a weight to anchor down the solar arrays. This system is complete and operational. It required an additional transformer, a 250 foot conductor, and communication equipment. I talked about the super sacks. It's got a single 50 kilowatt inverter. Again, you know, box power and the tribe worked to get along with the city to get this job done. There was significant on-site modifications, but cost savings from Buckland project really helped because we were able to learn from Buckland to move into this project. Next slide, please. So I'm going to ask Dr. Hirsch to talk about some of the data that was collected. Go ahead, Brian.
Great. Yeah, so thank you, Sonny. And so this is kind of a preliminary slide. What you see here in blue is the diesel, which is maybe a little ironic because probably typically we use that as black color. But anyway, the solar is that orange color. And then in Deering and Buckland, they both have wind power as well. You see here that the wind in green really only started again in July of this year. And what happened basically is the wind turbine was offline for over a year. And in part, actually, thanks to some other Department of Energy support related to an Intertribal Technical Assistance Grant Award, we were able to get that wind turbine back up and running. But right now, the focus, and we'll talk later about the wind and how we integrate all that. But for the solar, what you see here is approximate, well, you see 38,393 kilowatt hours that were produced in year to date 2021, and about the same, a little bit more in the 12 months prior to that. And you know, you see sort of an expected distribution in the winter time there. There's overall a larger load, a larger demand of electricity, and little to no contribution for December, January, and February. And so that's really where in the long term, the goal is for wind to kick in, and we expect to see much more wind production in the winter time. And so the overall load would be the same, but instead of it being all blue, there would be a lot of green for those main winter months. But yeah, this is sort of what we have right now. There is still some growing pains. I think we expect to see a little bit more solar over time that's actually fed into the system. There's obviously a constant amount of power produced, but it hasn't all been fully effectively integrated with the batteries and used in the overall system. So we do expect to see a little bit more over time, but this is the production that we have at this point in time for this time frame that we showed. So I think that's it for this slide, unless Sonny, you want to have any more comments on that one.
Yeah, just to go back to what we were talking about, we've got these systems built, and now we're in the follow-up and run phase, meaning we're going back trying to figure out how we can optimize the circuit, how we can make things better, how do we develop capacity within the villages so they have a better understanding of what we're trying to accomplish. Some of the things we had to go back and do and replace routers in both the powerhouses for Deering and Buckland. And we're trying to get to where we can remote in to be able to do our troubleshooting and our optimizing. We still have to get in from manual mode to auto mode. We've got some final commissioning laundry list to complete. We hope to do that this next year, but it's still a work in progress. And like Dave said, COVID-19 just set us back a whole lot. There were times where people weren't even allowed to travel into the villages. So next slide, please. So here's some of the design specifications here. I mean, it's a tilt angle of 45 degrees. Each box is about 15 kilowatt. Low wind locations means going to be less costly. Local hire was a priority for NANA. The trade-off between size and array and construction requirements optimize performance based on site-specific criteria and community needs. We mentioned that it was integrated with batteries, wind and grid-forming inverters, electric boilers that are in the powerhouse and the water plant, and it required sophisticated controls. Right now, we're replicating these solar projects, and we did it in Kotzebue, Shungnak, and Cobalt. We're going to give them more details there, and we're continuing to drive down costs, and that specifically deals with, when's the best time to do this type of work? Is it in the summertime, in the wintertime? What kind of building should we put in to protect the batteries? So next slide, please. So this is the largest, the third project. This is the largest project. It's a 576 kilowatt system that Kotzebue Electric Association, our partner, worked with. They hired Alaska Native Renewable Industries that Dave was talking about. And I must say before we move on here that these guys were extremely tough in this situation, because I remember going out there to look at the project when they first got started, and these guys were working in 30 below weather. And, I had stepped out of the truck and I immediately got cold, and I was thinking, man, these guys are tough. And they were having to get this project started during a pandemic and having to go through all the protocols and make sure that they social distance and not get infected from the community. So they had to isolate themselves at the KEA facility. But it just goes to show you how tough this project was, because that's tundra that you're looking at there. And these guys are hauling all these tools and equipment over the tundra and putting this thing together. And I'm just so amazed that they were able to do such a great job, Edwin Byfelt and his crew, and then the local hire. So they really did a good job. Next slide, please. This is the Kotzebue solar array again. It's the largest solar array in rural Alaska. It's 576 kilowatts. They put in bifacial solar panels, which is sort of interesting because they're going to take some solar production off the snow come March and April. And Alaska Center for Energy and Power, I believe it was ACEP along with UAF, was out there putting instrumentation on the solar panels to start to measure the type of production that they're going to get off the snow. So it's going to be interesting in March and April to see how much energy production that we get using bifacial solar panels. I think that's the standard equipment that we'll be using moving forward is bifacial. Once again, Alaska Native Renewable Industries, they came up and they trained our guys, our locals, how to work on these types of projects. And in Kotzebue, it also integrates with wind and batteries. Go ahead, Brian.
Yeah, Sonny, sorry. I was just going to jump in and say, despite like that earlier graph that you saw where solar was low contribution relative to wind, even in Kotzebue, where they also have an excellent wind resource, they are in process of pulling down some of these older wind turbines that you see right there in that picture that are old and in need of constant maintenance and repair, to the point where they're really not working very much and very well anymore. And they're using the communication infrastructure and some of the inverter protection and housing that is out at the wind turbine site already, and basically replacing wind with solar, because solar is just so much easier. Despite 30 below installation in general, solar doesn't have moving parts, as we all know, and it's just very reliable. So obviously it's not going to meet your needs in the wintertime, and they do have other large wind turbines, and they're looking at other additional wind for Kotzebue. But I mean, I think really where you do have both of the resources when it's available, that's really going to be the long-term solution. And solar does provide something that really no other renewable can provide much of the time. So next slide.
Thank you, Brian.
Yeah.
So we want to talk a little bit about this Shungnak project. We know that it's not part of the DOE grant, but there's something really important to mention here. The biggest value for this grant is that we learned how to do this in the Northwest Arctic. And I think we've developed a little bit of a reputation on, we know what we're doing. We're learning as we go, but we're bringing in different partners. And we started working with AVEC and, AVEC, the Northwest Arctic Borough, the tribes of Shungnak and Kobuk and Deerstone Consulting and NANA, all of us, I hope I didn't forget anybody, all of us working together to come up with a grant application to put a project in Shungnak that is intertied with Kobuk. So this solar array here is serving 2 communities. And this system had a different set of battery chemistry. It was Blue Planet and with an Agido control system. And this system is operational. It's a 223 kilowatt solar array with a 384 kilowatt hour battery. Once again, Alaska Native Renewable Industries came in and did this project. They had some trouble in the summertime because of all the wet weather that they got, but they did an excellent job. Right now, we're currently working with the Northwest Arctic Borough, Ingomar, on the IPP power purchase agreement that's in progress with AVEC. And the purpose of that agreement is to preserve power cost equalization, the state subsidy, when you integrate renewables into your microgrid. This project was funded by USDA, but it was really tailored after the projects that we've done in these other villages. Just gaining that knowledge and working together on putting a project together. So we're pretty proud of working with AVEC and the borough and the communities on keep replicating these projects. Next slide, please. Okay, so, Brian, pass it to you.
I know we just have a few moments here. And so what I just wanted to share is that, again, in the places where there is wind and solar, and Deering and Buckland and Kotzebue being the prime examples, without energy storage, i.e. batteries, to really integrate and both capture the energy and at times time shift it and not overwhelm your diesel generators, the solar really would have been challenged in terms of effective use of all of the energy production, because although it wasn't a large annual contribution for periods of time in the summer, it's a very large contribution relative to the load at the time. And so the point is that again, we're looking at this as a much bigger process and project than just a solar effort, for example. And so even for folks who have been sitting through the presentations today, there's been sharing among the different projects. For example, with what Dave is doing in Hughes, we had similar kinds of technology here. You see this is ABB power conversion. We were at the very end of the last iteration of their technology, where Dave and Hughes were at the very beginning of the next iteration. So this is kind of version 1, and what they have in Hughes is version 2. And so we were hoping that this was going to be there for a long time and that there'd be ongoing support. And while ABB is supporting this equipment, you can't even buy this equipment anymore. And it's, and it's just a few years old. So we've tried to kind of keep up with the technology. We're sharing, we're working, even talking to Igiugig about some of the same kind of equipment. And so all of us here, including AVEC, who I think we're going to hear from next, are sort of learning as we go along and sharing lessons learned. So next slide, please. And again, I know we're very close to the end. So just as kind of a summary here, the Deering and Buckland systems were the first and second utility scale wind and solar battery diesel hybrid systems where we were able to turn diesel generators off. Over time, we expect to have significant fuel savings. As Sonny mentioned, we're still sort of in that follow up and run phase, so we don't have it fully automated yet. The institutional financial structures to monetize fuel savings, that's really a fancy way of talking about power purchase agreements and preserving the power cost equalization efforts that are also being applied in some of these other projects outside of the NANA region as well. And DOE support has really helped us lay the foundation for a lot of that. At this stage, we're starting to encounter other challenges, such as when the diesel generators are turned off for long periods of time, we have to keep them warm because they're going to need to be turned on again at some point when the wind stops, when the sun stops, etc. And so it's a good problem to have, but it is a challenge. And I know, like in Igiugig, we've been talking about designing that in up front, whereas now in Deering and Buckland, we have to go back and kind of figure that out after the fact. So those are some of the challenges we've had, but again, those are better challenges than hoping that airplanes are going to keep flying and delivering fuel. So the next slide, and I think this is our last slide here. Yeah, you know, we're overlaying new technology with 20, 30, 40-year-old equipment at times. And so there's always challenges. And even our new technology is now 2 or 3 years old, and now it's out of date relative to what companies are coming up with. So, and then having, for example, ABB was the power conversion, and then we had SMA inverters, and they didn't always talk to each other. And so we literally had to get people from each of the different companies sitting on the phone for hours at a time, sharing proprietary data or coordinating different, very technical, detailed information in order to get all of this working together. And local turnover has been discussed several times. And in terms of cost and funding, we all know this is just very expensive. And right now, it is still dependent on grants. We're trying to get to the point where ultimately it's not anymore, meaning that the amount of fuel that we save is going to cover the cost of the project. But right now, we're not quite there yet. And so we still are hopeful and grateful for all of the funding that we get from folks like Department of Energy. So that's all I have. Sonny, if you want to wrap up or whatever you'd like to share here.
Next slide, please. Well, I just want to say on behalf of NANA and the Northwest Arctic Borough and all of our regional entities and our partners, thank you very much, DOE Office of Indian Energy, for being a great partner and supporting us over the years. Thank you so much.
Well, I have to say that it's been a pleasure to see all of these projects come to fruition, you know, and overcome the various challenges. So if anybody has questions, you know, please submit them now and we'll get to them after this last presentation. And I'll invite Forrest Button to give us his overview of their project. So Forrest, whenever you're ready.
So I got going there and then realized that I had to unmute myself, and I think last year that the program was unmuting us. So
yeah. There you go. We can, yeah, we can hear you now. You can start all over again.
Okay, so thank you, Lizana, and Carl, Dave, Sonny, and Brian. Thank you for your presentations. You know, all of us up here in Alaska, we tend to cross paths and work with each other quite a bit. Dave and I are working on some projects right now up around Minto we're trying to get going. Carl, RivGen came through earlier this year and did a presentation. They're trying to find some rivers that they could work on in our cooperative area. I'm not sure if we found one for them yet, but you know, we just work together all the time. And Sonny and Brian, we had our guys up there in Shungnak working with Sonny and Brian's crew on the RUS project. So it's really nice to for all of us to be able to get together and do these presentations. Next slide, please. So we've got a project, wind project going on in Stebbins that's going to benefit Stebbins and St. Michael's, as those two communities are intertied. And so ASHRA is what we call it. Next slide, please. So this gives you some information about AVEC as a company. We've got 58 communities that we serve. We're working on the 59th one, Twin Hills, that was just intertied to Togiak here this last year. You know, David pointed out that he's working with the community of Hughes, and they're a single powerhouse, and it's just the village. Whereas we've got, you know, 58 villages that we work with, so we've got some economies of scale. You know, we've got a full engineering department, a project development department, you know, customer service operations, a little bit bigger than most of the communities out there. So we get a little bit more synergy, I think, within our communities than just working alone. Next slide, please. So this kind of gives you an idea of just how big Alaska is compared to the rest of the United States. And, you know, there's that old joke that if you cut Alaska in half, Texas will be the third largest state instead of the second largest state. So we really do cover a lot of landmass up here, and each one of those little dots there represents a village that AVEC is part of our AVEC community. Next slide, please. And this is just giving you an idea of how big the state of Alaska is and how many different communities there are. Most of them are, in Western Alaska. Minto is kind of the lone wolf over there in the middle. And Minto is also one of Dave's villages within TCC, and the only village in the AVEC community that you can reach by road, which makes that one kind of unique for us. All of our other villages, it's either airplane or barge, and we've got a couple up in the northwest borough that it's airplane only. Where Sonny and Brian were presenting, really difficult for a lot of those villages up there that have to have flying fuel. Next slide, please. So this is just a little bit of a breakdown of what our costs are per kilowatt hour. And that large chunk in the middle, 22.53 cents, that represents our fuel cost. And, that being the biggest cost that we have, we're doing everything we can to cut down those costs. We talk about investment and return on that investment over time. And one of the things that's difficult for, I believe, most of the communities in Alaska is there's, all of us are not for profit. We represent our individual communities. And so there's no money there to, when you put in a wind project or you put in a solar project, to pay yourself back, because these fuel costs are just a direct pass through to the consumer. And luckily, we've got the cost equalization, power cost equalization program here in Alaska, which helps offset those costs. Our raw cost, per kilowatt hour can be as high as 50 cents. And with the cost equalization, that can come down to 25, 30 cents per kilowatt hour. So that really helps the communities out and makes it a little bit more affordable for the electricity. Next slide, please. So AVEC has invested pretty heavily in wind. We've always thought it's kind of more bang for the buck for the communities that we have. As the cost of solar has come down and the cost of batteries has come down, we're getting more and more interested in solar. Worked with Brian's group, Brian and Sonny's group for the project in Shungnak, and we actually went diesels off in Shungnak for a while this summer after that project was completely installed, and pretty excited about that. Looking forward to more solar projects with those guys in the future. So here's just kind of an overview of our wind program for 2020 and what we were able to do with the turbines that we have. We've got 2 900 kW turbines. The rest of them are 100 kW turbines. So we're able to, save money, and the big savings on these fuel charges, because PCE covers the first 500 kW that the residents have, but after that, the larger power consumers, the schools, the AC stores, they're paying full price, up to 50 cents per kW. So when we can take that, chunk of fuel cost out of that, it's quite a bit less for them, and hopefully they're passing those savings on to the consumers within the communities. So this picture that you see, the turbine, that's in St. Mary's, Pictus Point. It's a project that DOE helps fund, and I'll talk about that a little bit more towards the end of the presentation. Next slide, please. So AVEC partnered up with the Stebbins tribe to get the land and move this project forward, but there was really quite a few participants in this project. You can see the list there. One thing that I'd really like to point out is the city of St. Michael's and the city of Stebbins. Between the two of them, they put up $1.38 million of their Norton Sound Economic Development Corporation monies to move this project forward. So we've got, the partners in the 2 villages that we're going to be helping out here. are really committed to this project and are anxious to see it get off the ground and move forward. Next slide, please. This gives you an idea of where Stebbins and St. Michael are in comparison to Anchorage. It's about 420 air miles, kind of, excuse me, northwest. Next slide, please. And this just kind of breaks it down. So we're zooming in a little bit closer. You can get an idea where they are. That river that's running below them is the Yukon River. So that kind of puts it in perspective as to where these guys are out there in Norton Sound, Alaska. Next slide, please. So the city of St. Michael's, they've actually got a pretty good history. They started out as a Russian-American company, depot or installation of fort back in about 1833. And it's been a continuous village ever since. There's some information that during the gold rush of 1897, that there was upwards of 10,000 people camped out in this area. So they've got a pretty good history there in St. Michael's. Next slide, please. This is the community of Stebbins. It's kind of interesting. There's not a lot of history on Stebbins. What little I was able to find out is that they've been around since the late 1800s, early 1900s. But really the first recorded, in the U.S., the first recorded history of them didn't take place until the late until around 1950 when the first census occurred. And there was 80 individuals there in 1950. Next slide, please. So our project was to install a 900 kW EWT turbine. You can see the fuel offset is pretty significant. Net present value of $6 million, which is right about what the project is going to cost. So, you know, on paper it pencils. We've also got a wind to heat component where we're planning on putting a remote boiler in the St. Michael's well house. They pull their water out of a lake and pump it about 4 or 5 miles into town. So it's real important that they're able to heat that water up before they pump it. And it's pretty significant savings for them on that wind to heat portion of the project. Next slide, please. So this just gives you an overview of the Stebbins area, and you can see where the turbine's going up there towards the top of the slide. You would think that this turbine being 1.8 miles away from the airport, that there wouldn't be any issue with FAA, but unfortunately there is. Next slide, please. So you can see here in the airspace vicinity map that they are within the conical surface of the airport, and it also sits up on a little bit of a hill. So we've been working with the Department of Transportation here in in Fairbanks and the FAA, and trying to get the approach switched from left-hand approach to right-hand approach. And unfortunately, this kind of started right when the COVID pandemic hit, and it really brought everything to a halt. In order to change that approach, they have to replace the segmented circle on the ground in Stebbins, which DOT wasn't willing to do in 2020. And so that put it off until 2021. They finally got that changed, and then they had to file a notice to airmen, which essentially, you know, lets everybody know that there's this change in progress, and find out if there's any concerns or comments from the pilots that fly in and out of there all the time, and any of the airline companies that fly in and out. So the latest iteration of this is apparently when they filed their notice to airmen with the FAA, they filed it incorrectly, and even though it was, they changed it from left-hand to right-hand approach, they had it coming in on the wrong end of the runway. So I spoke with FAA this last week. They went to DOT. DOT is filing an application to amend their NOTAM, And the latest that I've heard from Bill at the FAA is that hopefully by the end of the month, they will have issued their 7460 permit for construction for us to finally move forward with this project. Next slide, please. So here's our latest and greatest schedule. We've already purchased the turbine. Unfortunately, because of the holdup, it's still sitting overseas. We're getting a little bit nervous, even though it's not supposed to be delivered until second quarter of 2023. We're a little bit nervous about transportation with kind of the worldwide supply chain issues and getting stuff in and out of port. We've got another project that we're working on right now where we're actually having some really bad problems getting some equipment out of Germany and over here to Alaska. Next slide, please. So I wanted to talk a little bit about the project that we had in Bethel and in St. Mary's Pickett's Point with Tribal Energy. They've been just great supporters of AVAC in our communities over the last several years. And, just looking at these numbers here, combined between Bethel and St. Mary's, we've saved $2.5 million for the people in our communities. Again, we realize they don't see 100% of that because of the PCE in Alaska, but any savings for those people over 500 kW is significantly impactful. And the impact that Tribal Energy has had on Alaska over the years, I don't think we can say enough about. We've had 4 presentations here today, and each one of them is with help from DOE Tribal Energy, putting up the money, the investment in Alaska, so we can help bring down the electric costs and allow people to continue to live a good subsistence lifestyle in rural Alaska. Next slide, please. So I think everybody knows me from past projects. I tend to talk a little bit fast and run through these. Maybe next time I can go first, and then Dave can have more time to do his, because we all know that Dave really likes to talk about his projects, and he's always got more slides and more interesting stuff, it seems like, than I have on mine. So thank you again for the opportunity, Lizana, and thank you to everybody that presented here today.
Thank you, Forrest. I don't know. All of these projects are near and dear, and obviously, it's so inspiring to see you guys overcome all the challenges, for the community. So thank you all. And we'll let you go first next time, Forrest, because David definitely needs everybody's extra time. So I'm gonna pass it over to James to moderate the questions. And so James, you're up.
All right, thanks, Lizana. So we have time for questions. It looks like about 10 minutes. We have a couple, but we have time for more. So submit any that you have in the chat function. All right. First question here for all the solar projects. Can you give us any details on their performance or relative production relative to what was modeled? Are they performing as expected? I know they're relatively new, but what do you know to date? Let's start with Dave.
Ours, we don't have good production information because that it's too large to just turn on and it would backfeed the generators, because it's about 120 kW system and roughly 70 kW base load in the community. So we don't have good production data for that site, but I can say from other sites, a general rule of thumb that I use in the interior is that roughly 1 kW of installed solar in the interior will produce about 1,000 kilowatt hours over the course of the year. And that's going to fluctuate depending on weather, but that's a very good rule of thumb that I've found to be reliable. And I'd let Sonny or Brian comment, because I know in Shungnak and Kotzebue, they came in, those were done after bifacials had kind of arrived on the scene, and the expectation on bifacials is that there'll be between 10 and 30% additional production in our climate. So that is really cool. In any future project moving forward, we'll definitely be trying to utilize bifacial panels, but that's what I'd have to say on Hughes.
Yeah, so this is Brian, and for Deering and Buckland, actually, we those are the exact same rules of thumb that we have used, and in our monitoring of it, actually, it's been a little bit better than that. So typically that translates into about a 10 to 10.5, almost 11% capacity factor, and I think we are a little bit over 11%. And again, it's similar to Hughes. We don't have quite the same issues with loading on the system. That it's a little bit easier for us to measure than because the solar is, especially like in Buckland, it's a 50 kilowatt solar system, and the loads are in the 200 to 300 kW. So we can kind of let it run on its own. And there have been times where the battery hasn't been operating fully, but the solar is still producing. And so, yeah, we can say that it's by itself performing quite well. When it's integrated with everything else, there are times when we've had some losses. That is what we're really working on. And as far as the bifacial issue in Kotzebue, I actually don't have the exact numbers on that right now. I think that's correct, that it's probably more on the order of 10%-ish that it's improving above the baseline. But actually, I think the situation is that in the first year, which it's just been operational for a little over a year, there were some times when the system was offline for various reasons. So we don't have a full year yet to make definitive statements on that. I think that's actually why, I don't have all those numbers at this point. And Sonny, maybe you have some more of that, or you've talked to Matt lately or something like that. I'm not sure.
No, Brian, we don't have all the data from Deering and Buckland. At some point, we're hoping to put the Buckland data out into the cloud so we can make that visible to everybody. I think it still goes back to that, we're still doing follow-up and run. We've got final commissioning that we need to do. And about this for the solar sites, I think it's just going to be a work in progress. One of our goals is to go back and right size those solar arrays for the communities. And if we can demonstrate the DOE tribal loan program for the tribes doing that, that might be a good start off project, is adding more solar into Deering and Buckland and Kotzebue for that matter. Thanks, James.
Certainly. Thank you. In terms of next question here is, I guess for the storage projects, the battery storage projects, I believe they're all lithium ion, with the exception of the Igiugig project. I'm not sure what it was, but I think Sonny, you said it was a different chemistry. The question is very general. Like, it sounds like the storage technologies continue to evolve in cost. Is the chemistry pretty settled? Like, it's lithium ion is what everyone's using, or are there other battery technologies that are out there that are promising for Alaska application?
So they're all lithium ion, but there's different chemistries within the lithium ion family. And so I don't think that's fully settled right now. And anybody else, please jump in here. What seems to be evolving is that the battery chemistry in Igiugig and Cobalt is lithium ferrous phosphate, which is an iron chemistry, which it's less energy dense. So it's not as compact, and so it's actually not as costly, at least the purchase of the equipment, but shipping it is more expensive because it's sort of a heavier volume to energy content. But the upsides of it are that it is a cheaper upfront cost, and Cobalt, which is in the Deering and Buckland batteries, and Kotzebue's for that matter, it's nickel, cobalt, and manganese, NCM. The cobalt is really volatile in terms of expense, and actually has a little bit more volatility in terms of fire hazard as well. So NCM was the preferred chemistry for quite some time, but I think throughout the industry, people are looking at that right now and thinking a little bit twice about that. It's a little bit more expensive, it's more energy dense, it's easier to ship from a cost perspective, but it's more hazardous. And if you're just talking about space in a building, it's not that big a deal. So if you're in an automobile, you want the most intense energy density you can possibly get, which is NCM chemistry. So Teslas and other electric vehicles are using NCM lithium ion technology. But for stationary power applications like we're talking about, it seems like the industry, especially at the scale that we're talking about, which isn't huge, is moving more toward the phosphate batteries. So the ferrous phosphate batteries. So yeah, I don't know. Anybody else want to jump in there? Dave or others?
I would just note, and Brian kind of touched on it, but a big thing is the volatility or the safety. And lithium iron phosphate is typically, or lithium ferrous phosphate, like the blue ion batteries, is typically a more stable composition. So there's all kinds of marketing, and you can believe what you will, but long story short, if you're in the marketing side of things, and they tell you that the lithium ferrous phosphate batteries won't explode like the ones in Arizona's battery fire and the Boeing fire, there's been a number of issues. So that's one of the big marketing factors for the lithium ferrous phosphate. I would say that and that's not what we're used in Hughes. In Hughes, it's an NMC composition. It's in their ABB batteries, or I think they're Panasonics, but I can't quite recall. But yeah, lithium ion in general is kind of, and what's driving the market obviously is not Alaska. What's driving the market is in large part California, the electric car industry, et cetera. We're just kind of hanging on the coattails of the market and trying to follow it and hoping that it leads the prices down. But as they put in big storage requirements in their renewable portfolio standards, Alaska is most certainly benefiting from it.
Mm-hmm.
Great, thank you, guys. This is a question actually from, go ahead.
I would add that AVEC just ordered some modules out of Germany, and we specifically specified the iron phosphate, or excuse me, the ferrous phosphate, because they pretty much guarantee that you're not going to get a runaway fire in those. And when you're installing any kind of a battery product in a remote site in Alaska, fire obviously is a huge concern. Thanks.
Thank you, Forrest. Another question here tied to technology, I guess, and this is the bifacial modules. How much of a price premium do you pay to get bifacial modules? Does anybody have a rough estimate of additional cost?
I'll throw in there, because I was actually kind of I have a side business where I do solar PV, so I've got some level of expertise on this. And what I'm seeing anyway, is that as bifacials kind of come in, there's not really any price premium, maybe a few cents a watt, but your bigger determinants are going to be what your wholesalers that you're buying from, kind of A, what your quantity is, and B, what your wholesalers have in stock. So, I've most certainly seen some bifacials that have come in at a lower cost of monofacial panels. And so it's really, they're very comparable in terms of cost. And when you look at the LCOE, the price per watt is in some ways is better. So it's kind of, I don't know, in my world, kind of becoming a standard if you've got a fixed mounted array, that you could get some potential backside gain. And I would also add, unlike other, technology changes, there's not really any risk to this technology change, because it's not any highfalutin science behind it. There used to be a white sheet behind it. The solar manufacturers removed the white sheet behind it and put in a second glass plate. So there's no real technological changes. It's just different manufacturing processes. And so that's my response, is that there's not much increased cost at all.
In Kotzebue, I think we bought solar panels, and then they said, oh, we don't have the monofacial ones. We'll tell you what, we'll give you bifacial ones for the same price. And I don't know everywhere if moving forward they're going to be the same price or not, but in Kotzebue they were. And yeah, it is going to be a production gain. So it is probably, hopefully, standard moving forward. I would agree.
Great, thanks, guys. A question here for Carl on the Igiugig project. Those RivGen units, what's their rated output, and do they operate at full power production, or is it dependent on current flows throughout the year?
So they're both rated at 35 kW. We do see variation in that throughout the year as our river volume changes. We haven't had a full year of operation without having to modify them. So when we originally put the 2.1 in, it was actually exceeding what it was rated at, but we had a few hitches in that there was some damage to it and things like that. So that one is being reconditioned right now, and the second one, we took into account any problems that we had with the first one, and that's also rated at 35 kW, but we're still in the middle of integration right now, and so we haven't actually tested that. But based on our results from the first RivGen, I think we should hit pretty close to that number of 35 kW each.
Great. Thanks, Carl. With that, we don't have any questions or any further questions, I would say. So I'll pass it back to Lizana to close us out.
Well, thanks, James. Again, I wanted to thank the presenters. It's always great, and I know you've had challenges, each of you, with your projects. So it's great to see how far you've come. For the attendees and anybody else joining us tomorrow, we're going to start at 10:30 Mountain Daylight Time, and you will need to either register for those sessions and join via the particular links for each of those sessions. And with that, again, I want to thank all the presenters we had all day long, and thank you for your time and attention. And I think we'll end now. Goodbye.
Thank you.
Thanks, guys.
Thanks. Goodbye.
Thanks. Bye.